Hey Calibrate Tools family, welcome back. Today we're going to learn how to use a tool that's so useful whether you're a professional or just a DIYer. It's called a soldering iron. Hey, think about those electronics projects that you got to work on. This is a no-brainer when it comes to connecting those wires. Let's see how it works. Okay guys, this is a soldering iron, and you may have heard the terms brazing and soldering. Well, what's the difference between brazing and soldering? The difference has to do with the temperature at which the filler metal melts. Filler metals melting above 840 degrees Fahrenheit or 450 degrees Celsius are considered brazing materials. Any materials melting at or below those temperatures are used for soldering. So now that we know the difference between brazing and soldering, we have a soldering iron, which consists of an insulated handle to protect your hands from the heat. We have an iron, which is this metallic cylindrical portion here. And then we have the tip, which sits inside this cylindrical portion here we call the iron. Now this tip is removable. Just in case you want to use another type of tip, you just unscrew the set screw right here, take it out, put the new tip in, tighten it up, and you're good to go. So in this case, for this soldering iron, you're going to need a very thin flathead screwdriver to access this screw here, this set screw. You don't have to take it out all the way, just loosen it, pull out the tip. If you're going to put another one, put it back in. And make sure, guys, when you put it back in all the way. Because if you install it like that, halfway or not all the way, and you tighten it up, you'll go to solder and you'll notice that you're not getting enough heat, that it's taking forever for the filler metal to melt. You have to seat the tip all the way in so it contacts all parts of the iron, even the bottom part that you can't see, okay? Then you should have no problem melting the filler metal as quickly as possible. Now, if you notice, this tip is pretty sharp. Why? Because if you're doing pretty intricate, precise applications and you need that precision, you want to use a sharper tip. If not, if it doesn't require as much precision, you may want to use a tip like this. Now, soldering tips are characterized by their shape and they're classified by their series. This right here is probably an I series tip. It's conical, but it has a needle-like shape to it. Okay, it's very pointed and it's for very detailed work. This right here has a chisel-like shape to it, and it's probably a D series. The surface area of this tip is much bigger than this one, obviously, and that's because you'll be able to transfer more heat from this tip to your material, okay? Especially if you're soldering thicker material. If it's very detailed work, you don't want too much heat to be transferred, so you're gonna have a sharper tip, which also allows for more precision. So you got many types of tips. You got the K series, which is for a knife-like tip. It's shaped like an X-Acto knife. You got the B series, which is more of a conical shape. It's not as sharp as the I series, but it has a conical shape to it and a pointed tip as well. Then you have the C series, which has a bevel-like shape to the tip. And then you got all kinds of specialized tips. Depending on your application, you can have specialized tips made, custom tips made, and all of that. Just know what kind of soldering you're going to do, whether it's very precise detail work, general purpose soldering, or what they call drag soldering. The C series and the K series tips are good for that. So this is the solder right here, and this is what melts and forms the bond between the components that you're melting. It's usually in a wire form like this, but it can come in other forms, especially in the brazing process, but we're talking about soldering here. It's made up of tin and lead or tin and copper. Now, because of the health and safety risks, as well as some environmental risks of lead being in your materials or just out there, lead-free solder has become more popular on the market. There's even certain types of solder that contain flux inside of it to reduce the oxidation on the metals that you're soldering to produce a better bond. Kind of reminds me of flux core welding, where the flux is inside the electrode and it shields the arc from any contaminants, producing a better weld. Pretty interesting similarity there. And soldering irons usually come with a soldering iron stand. That's one of these right here, okay? You can just put it down like that and rest your soldering iron on it when you're not using your soldering iron. It's for safety purposes. And remember, you don't want to place your tip on the stand like that. You want to place the iron on the stand, okay? That's how you want to place it. But this handle right here also has a flat part. So if you have your soldering iron on the table or surface, it won't roll on you because you have that flat area on the handle here to keep it in one place. Otherwise, if this was all round, it'd probably roll on you, right? So I think that's a pretty good feature right there, along with the soldering iron stand. And in order to get the maximum performance out of your soldering iron, you got to make sure that it's clean. You got to have some cleaning materials nearby. That can be a damp sponge, it can be a cleaning pad, it can be steel wool or brass wool. Okay, I got a pad here. I'm gonna spray some alcohol on it, and then I'm going to clean the tip here. And make sure you got some safety glasses to protect your eyes from the fumes from the soldering process, because that's not healthy or good for your eyes either. And if you have a fume extraction system around to suck those fumes out of the soldering area away from you, that's even better as well. Okay guys, so I'm gonna open up a new packet of solder here, and this one says lead free. All right, so when you're looking for that lead free solder, just look for those words right there on the packet. It should tell you. And it comes in this plastic container, and you can just draw it out as you need it. You want to clean the solder if you can as well, okay? So you can spray that off with some alcohol. Wipe that down. All right, guys, you can't stress enough how important it is to clean your tip, okay? And after you clean your tip, you want to perform a process called tinning on the tip, because even though I wiped the tip off a few times, the tip still has a dull finish to it, right? You want a shiny finish to the tip, all right? And that process called tinning will achieve that for you, because after you finish soldering, the tip will be oxidized. That means it'll have darker areas on it, and that will reduce the conductivity of the heat. In other words, it'll make it more difficult to transfer the heat from the tip to your solder, to your filler metal, to your material. Applying a new coat of tin to the tip or tinning the tip before you start to solder will make it easier for the heat to be transferred to your filler metal, to your components, and it'll make the soldering process much easier. Okay, so I'm gonna get ready to tin this tip, but I have to plug it in because this is a corded solder iron, okay? So stick with me. Okay, that soldering iron should be nice and hot. So to tin the tip, you just want to cover it with a thin layer of solder. Got a nice shiny tip there, guys. Okay, so this is a switch that I got out of a welding gun I was doing some repairs on. Okay, so we're gonna take some wire and solder it to one side and then solder it to the other side and check for continuity just for posterity's sake, okay? But let me go ahead and cut off that old wire there. I'm gonna take my needle nose pliers and put the wire in the snipping section right here. Most pliers have a snipping section right here, okay, by the pivot. And I'm gonna go ahead and snip that off. Get that out of there. All right, so let's test for continuity first before we do our soldering. The way you do that is you take a multimeter or a voltmeter, like this one right here. I'm gonna take my leads. I'm gonna turn my multimeter to the continuity setting to check for continuity. That's this right here. That's the continuity setting on the multimeter. It has a diode symbol and a sound alert symbol right there. That's what we want, right? Because if there's continuity, it's gonna make a sound. If not, well, it's a bad switch. So let's go ahead and put our leads, one here, one there. I'm gonna press the switch. Okay, we got continuity. The switch is good. So when we test for continuity after we do our soldering, hey, we'll see if our wires are good too. Okay guys, if you haven't noticed, this is not an adjustable solder iron. There's no soldering station where you can turn a knob to adjust the temperature. If you do know the temperature at which to set your machine, if you have an adjustable solder iron, go ahead and set it there. The minimum temperature on this soldering iron, on this brand, is about 400 degrees to about 470 degrees Celsius. That's fine for what we're gonna do right now. Like I said, if you have an adjustable solder iron and you know the settings that you need to set it at, go ahead and do that. Okay, so I got my wire here, and we're gonna solder them to one end and solder another one to this end. But I need to strip them first, okay? So I'm gonna take my stripper crimper, and I'm gonna put it in the 16 gauge slot here. So after I strip the ends of the wires, I wanna twist them nice and tight. This is stranded wire, so you gotta make sure you twist them nice and tight. So the first thing I wanna do now that I have a nice hot soldering iron is heat up the base metal here. And I'm gonna add some solder to it. Like that. And I'm gonna take my wire, I'm gonna place it in, then I'm gonna heat up the base metal again. Then I'm gonna take my solder, okay, so we got one done. It's a good connection right there. Now let's get the other one. Formed the solder, and I took the wire, I placed it in the solder, let it cool, harden over the wire, at least the bottom part of the wire. Now I'm gonna place some more solder over the wire. All right, guys, so I let it cool. We got a decent connection here. So let's test for continuity. Well, I guess the wires are good. All right, guys, so that's how a soldering iron works. So if you're into electronics or the wiring is loose on some equipment you have, get a soldering iron. Most likely you'll need it, especially if you got bad wiring. If you like what you saw, hit the like and subscribe button, hit that notification bell so you can get more of this great content, and I'll see you next time.